Hello geometry students. In this video we are going to learn about a parallelogram that is called a rhombus and the special properties of a rhombus or rhombi, which is the plural of the word rhombus. We're going to solve for missing side lengths and missing angle measures using all the properties that we're going to learn about. Okay, let's begin. So, since a rhombus is a particular type of parallelogram, it will have all of the properties of a parallelogram. So those 5 properties that we should know, repeating to ourselves, 5 properties of a parallelogram. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. That means they add up to be 180 degrees. And the diagonals bisect each other. Okay. Now I'm not going to put all of those markings on our figure just yet because when we get into some specific properties of rhombi, that's going to change our markings a little bit. So let's talk about the properties that are specific to a rhombi. They have all these 5, and in addition, they have their own special properties, 3 extra properties for rhombi. The first of these special properties is it has 4 congruent sides. Second is that the diagonals are perpendicular. And perpendicular means they form 90-degree angles. And the last one is that the diagonals bisect opposite angles. So it splits them in half. Cut in half. Equal parts. Okay, so let's see, how do all of those marks come to play on our figure? Well, the opposite sides are parallel. So that's like we've had before. Top and bottom will be parallel. And our left and right will be parallel. And the opposite sides are congruent. And in this case, for a rhombus, all 4 sides are congruent. So all of these will have 1 mark on them. And then we have our opposite angles that are congruent. I want to use my colors, so I'm going to mark these up right here. In this case, angle A and angle C, they are opposite angles. They would be congruent to each other. And also angle D and angle B are opposite angles, so they are congruent to each other. And the consecutive angles are supplementary. And my picture right here, green angle equals green angle, blue angle equals blue angle, and blue plus green equals 180. And the diagonals bisect each other, means they cut each other in half. So these 2 will have the same length, and these 2 parts will have the same length. And then for the special properties, the 4 congruent sides, we've already marked that. The diagonals are perpendicular. That means they form 90-degree angles. So that means this right here is a right angle, and this is a right angle, and this is a right angle, and this is a right angle. All of those angles inside here, all by the diagonals, they are right angles. And then the diagonals bisect the opposite angles. Now, how is this different from statement 5 up here? Diagonals bisect each other. Well, when they bisect each other, that means the diagonals are cutting each other in half. The segments are being cut in half. So we end up with AE and CE the same length, DE and BE the same length. When it says the diagonals bisect the opposite angles, it means it takes that big angle, that corner, that vertex angle, and splits it exactly in half. So angle A up here is being split into 2 equal parts right here, and angle C is being split into 2 equal parts down here, and all 4 of these parts have the same measure. Same idea with our other angles, D and B. This angle right here is congruent to this one right here, which is also congruent to this one up here, and this one over here. And so all of these are the same. Now that doesn't happen with a plain old parallelogram. That doesn't happen with a rectangle. That only happens with a rhombus. So now I think we have all of our information on that picture. Now let's solve some problems involving a rhombus. Okay, in this diagram, RHOM is a rhombus. Solve for sure. CRHOM, and we've got the diagonals meeting at point B. Okay, so first off, The measure of angle HBO equals 14n plus 6. So we're going to solve for that variable. Okay, so let's figure out where is angle HBO. I'm going to highlight that. Angle HBO. Okay, that is this angle right here. It is formed by the diagonals. And going back to our properties just a moment ago, we know that the diagonals are perpendicular. They form 90-degree angles. So that means this must be a 90-degree angle. And that one also. So how does that help us? That means that angle HBO is 90 degrees. So 14n plus 6 equals 90. And now you can go to Desmos and type this in, or you can use algebra. I'm going to go ahead and use algebra right here. But you can absolutely type it in Desmos, but if you type it in Desmos, remember that you always want to use x as your variable. This will give us, using algebra, 14n equals 84, and when we divide by 14, we get that n equals 6. Now we should check that just to make sure that makes sense. If we plug it in, 14 times 6, 84 plus 6 makes 90 degrees. Good. Our second part of this problem, we have RM and MO. RM is a side of this rhombus, and MO is a side of this rhombus. And going back to our properties, we learned that a rhombus has 4 congruent sides. So all of these sides are congruent to each other. That means this, and this, and even this, and this would be equal to each other. So we know that RM is equal to MO. So we just write an equation that says that. RM is 13x minus 7, and MO is 8x plus 13. Now you could type this into Desmos. If you type that in Desmos, you've already got the variables x, so you just need to look for that vertical line, and that tells you the solution. If you're going to use algebra though, as I'm going to do right here, let's get our variables on the same side of the equation and our constants on the same side. Let's subtract here, that gives us 5x minus 7 equals 13. Let's add 7 to both sides. Running out of space here. I'll carry it over here. We get 5x equals 20. And when we divide by 5, we end up with x equals 4. Now, does that number make sense? Let's plug it in. Let's just make sure. If I plug in right here, 13 times 4, that's 52. 52 minus 7, that means RM is 45. And if we plug it in right here, 8 times 4 is 32. 32 plus 13 is also 45. There we go. Their sides are equal to each other. Excellent. Now our third problem down here is about some angles. We have measured angle MOB is 12y minus 7, and HOB is 5y plus 7. Let's highlight those angles. MOB is this angle right here. Hang on, maybe I will take one of the colors off of here to help out. How about that? MOB is this angle right down here. And HOB is this angle right over here. And we learned our special properties of rhombus. The diagonals bisect the opposite angles. So those two parts are equal to each other. This part and this part are equal. Angle MOB is congruent to angle HOB. So that means 12y minus 7 is equal to 5y plus 7. Now you can type this in a Desmos. Remember to use x as your variable if you're going to do that. Or you can use algebra, get your constants on one side and variables on the other. Head right here, that's going to give me 7y minus 7 equals 7. And if we use our algebra here with 7 over, we get 7y equals 14. Divide by 7, and we get y equals 2. Let's check to make sure that makes sense. If we plug it in, 12 times 2 is 24. 24 minus 7, that gives us 17. And if we plug in right here, 5 times 2 is 10. 10 plus 7, 17. Those are equal. Good. Okay, let's do a few more examples. In this problem, JKLM is a rhombus, and the measured angle KJL is 34. Let's find the measured angle JKL. Okay, let's see if it goes here. KJL is 34. KJL is this angle here. And we are trying to find JKL. We want JKL, which is this big angle up here. Okay, so we have a couple of different ways that we could do this problem. I'll talk about a couple different ways. KJL is 34. One way that we could do this problem is that we could say, okay, we know that this is a right angle right here, and then we could find our angle right up here. We know that the angles in a triangle have to add up to be 180 degrees. So we could use our 34 and our 90, and we could subtract, and we would get that our angle right here is 56. That's a whole angle. That's all half of it. JKL is the whole thing. If this is another 56, the angle JKL would be 112 degrees. Another way that we could solve this problem, if we wanted to, without using the right angle right there, we could have said, okay, we know that this is 34 and this is 34. So our big angle right here is 68, and this big angle up here is also 68, and we know that, well, this is opposite angles, and we know that these are consecutive angles, they are supplementary, so they have to add up to 180. So if this is 68, then 180 minus 68 will be 112. Two different ways that we could do this problem. I think I like the second way better. Another problem. If BCDE is a rhombus, BF is 10, and CF is 7, find BC. Okay, what do we have there? BF is 7, so that is right here. Excuse me, BF is 10, so that's it. And CF is 7 here, and we are trying to find BC. Well, one of them is part of one diagonal, part of the other diagonal, and then we've got a side of a triangle. What can we do with this problem? Well, this one is going to rest on the fact that our diagonals are perpendicular. Perpendicular means we have right angles. And what we have here, this shape formed by these three colors, is a right triangle. So if this side is 10, and this side is 7, and we're trying to find this one over here, that's the hypotenuse of a right triangle, we can plug this in to the Pythagorean theorem. The Pythagorean theorem, remember, says that a squared plus b squared equals c squared, where c is the hypotenuse. So 7 and 10 would be our a and our b. Doesn't matter which one we put in which place, as long as we have that this c is our hypotenuse, or c or x, or whatever variable you prefer to use. And then we could plug this into Desmos, or we could use algebra. If we use algebra, 7 squared is 49, 10 squared is 100. We add this up, 149 equals x squared. Of course, that's not the side of the triangle. Side of the rhombus, we need to take the square root there. And if we take the square root of 149, we end up getting that x is about 12.2. And that makes sense because as the hypotenuse of a triangle, it should be bigger than either of these two sides. So that is a reasonable measure. Okay. Now for our last two problems, these aren't labeled for us. It says label rhombus GOLF below. Solve for Y, GO, and OL. So the only thing you need to know about labeling is that you can start wherever you want to, but you have to go in order. So you could put this first corner G wherever you want to. I'm going to put it right up here on my upper left, because O, L, F. Again, it doesn't matter, you can go clockwise or you can go counterclockwise. You can start at any vertex, but you do have to go in that order. And then all of our sides are going to be the same. So it doesn't matter which one you would really call what, but they're all the same. So if GO is y plus 1, and OL is 2y minus 5, we know that these sides are the same, so we're just going to set up an equation. GO and OL are equal, so y plus 1 is equal to 2y minus 5. You can plug it in Desmos if you want, so that you can use x as your variable, or if you want to use algebra, let's see, let's subtract y. 1 equals y minus 5. And 2. Okay, so we get that y is equal to 6. We were asked to solve for y and GO and OL. So we have that y is 6, GO, well that's y plus 1, 6 plus 1 is 7, and OL is 2y minus 5, so if y is 6, 2 times 6 is 12, 12 minus 5 is 7. And our last problem that we're going to do here, label rhombus BSKT and join diagonals intersecting at point A. Same rules for labeling as last time, you can start wherever you want, but you do need to go in order. Let's put BSKT and join diagonals intersecting at point A. They intersected point A right here. Okay, and then we are told that the measure of angle ATK is x plus 10. ATK is this angle down here. And ATB, well, let's see, ATB is 4x minus 35. ATB is this angle right here, 4x minus 35. We know that the diagonals bisect the angles. So this part, this big angle BTK, is split into congruent parts. So those two parts are equal to each other. Angle ATK is congruent to angle ATB. So that means x plus 10 equals 4x minus 35. We can use Desmos or we can use algebra. We can use algebra here. We get 10 equals 3x minus 35. We'll add the 35 to both sides. It ends up with 45 equals 3x. And if we divide by 3, we get that x equals 15. And we were asked to solve for x. If we plug it back in though, do our numbers work? Let's see, if we plug in 15 plus 10, that would be 25. And if we plug in 15 right here, 4 times 15, that's 60. 60 minus 35, 25. Our angles are equal. There we go. And that is how we use the properties of the rhombus to solve for missing values. All right? If you have questions, make sure to ask during class.